we'll go ahead and practice while some of you are still here. This is on your papers that was handed out to you. Okay, so we'll go ahead and look at the bottom of page 2. All right. So if you had to describe that, what is the first compound? What is this? Hydrogen chloride plus. Okay, so plus zinc. Okay. And then what's on the... Okay. Okay, now, everything on this side of the reaction is called what? Those are reactants. What's on the right side? Those are products. These are reacting with one another to produce what you see over here. Now, this is a choice that you can make. Once you get better at these, you probably won't do this anymore, which is fine, and that's what I mean is underneath here, just write all the different elements that you see in the reaction. Okay? So when we say left, we mean on the reactant side. So what's on the left side of the arrow? So hydrogen's left. Hydrogen's right. Chloride's left. Chloride's right. Zinc's left. And zinc right. Okay? So then you'll also notice that you have these blanks, and those represent what's in front of each one of these. And as of right now, you have just ones in there. Okay? So every number is a 1. So nothing has changed yet. So as far...
So we write down the ones?
No, you can do that at the end.
Where'd you get those ones from?
There's nothing in there yet.
Since there's no numbers to that.
Okay? So there is a 1 in front of each and every one of these. Okay? What happens if you take 1 times a number? Yeah. So nothing, what different number?
It equals the different, whatever number you choose.
You get the same number back, correct? Yeah. So what I mean is, what's 1 times 1? That's what we've got. What's 1 times 1? Yeah, so nothing has changed. Okay? So, what is it that's out of balance from the left and the right-hand side? Hydrogen is 1, and zinc is another. Or, excuse me, chloride is another. So, what you would do then, okay, we use what's called coefficients. We're not going to get to that today. I forgot Mr. Hemmer had come around yesterday asking about that. That was in the afternoon class about Ash Wednesday. But anyway, we have just a little bit of time left. What we put in front of the entire compound is called a coefficient. So right now there's a 1. 1 times 1, 1 times 1. Okay, do we understand where that's coming from? Okay, so we just use, by trial and error, try a number 2 here. Okay, and that gets distributed through the entire compound. What we mean by that is, let's say we had some zinc nitrate. Okay, what do you have to do with that number 2 there? That has to be distributed through everything that's inside the parentheses, and that's what we mean here. Okay, so this gets distributed through the entire compound. What is 2 times 1 for hydrogens?
2.
That gives you 2. Okay? So then you can put an X through there, a slash, or whatever it is, or you can just write it like that, but just don't get that confused with that being 21 now. So our hydrogens are now balanced. but our chlorides still aren't, but this has to be distributed, so 2 times 1 gives you what?
2.
So now what you have on the left-hand side balances what you have on the right-hand side. So, did any of these numbers change? First one did. So we changed that from a 1 to rather a what?
2.
You put a 2 there. That's it.
So we have to match up left to right, not top to bottom.
Left to right, yes. Well, when you say top to bottom, I'm presuming that's what you mean here. So I guess you could say both ways. Depends how you ask or describe it.
Wait, so for the hydrogen and chloride, since they're together, you have to get 2 no matter what?
Yes. All right. We'll go ahead and do one more, and then. So on page 3, go ahead and pick any one of those.
The third ones.
Age 2 plus.
The third one.
Let's just do the first one.
The first one?
First.
Oh, okay.
He's gonna do almost the exact same thing.
So we've got H2 plus Cl2, and these are written by themselves. This element, and this element, when those are written by themselves, gases and halogens, what does that tell you? I believe you said it yesterday. If it wasn't, it's diatomic, okay? Notice you don't have those 2's over here because they're not by themselves anymore, okay? There is 1's in front of each one of these. What are some elements that you see?
Oh, we see hydrogen, chloride, and that's it. That's it.
Hydrogens.
2 for 2 and 1 left side. 1. 2. 1.
Okay? So there's only one place we can go. These are out of balance. These are 1's. So what do we put in front of here?
A 2 so that it's balanced.
Okay? So that changes that to a 2, changes that to a 2. You distribute that through the entire compound. So what are our numbers here? 1, 1, and 2. That's it. Okay? How do we know how to? You mean this here?
Yeah.
Well, because there's only 1 there, you have to multiply it by something to match up what's on the left-hand side. You could say it's the least common multiple if you wanted to, if that helps you out, in a matter of speaking. Okay?
Can we do the next one down?
Calcium.
Let's save that for another day.
Let's do a harder one just to see what it's like.
Well, the second one's
No, we should do that with another.
Yeah, with the other.
Well, you tell me. I don't care.
The second one?
Nah. Have fun cleaning the shop.
The second or the third one? Which one? I can't hear you.
Guys, stop talking. Stop talking. We're actually learning. Okay, what are you guys gonna do after this?
So as we've just illustrated in balancing these reactions, what's on the reactant side has to balance with what's on the product side. Okay? And when you do that, you are satisfying what's called the conservation of mass. I know. Yes, I agree. Yes, we've already done this. But for some people, if they want to choose to catch up, they can do that right now. Does everyone have this content? I heard a no.
What? I'm trying
Okay.
to teach you.
All right.
Yep, I'm not playing basketball next year. This was when I was 2 inches from
It's pretty easy. So this one is.
Okay, so how many of you, I don't know what you, since you're leaving for Ash Wednesday on both sides of the altar, you probably have candles on each side called, what is that, an abra? I don't know what it is you have the candle stuck in, calabra, something like that. But how many of you have used those to light the candles? It looks like a bell on the end.
Oh yeah, that thing.
Looks like a bell on the end. And then on here you got the little wick to light the candles. Okay. So what you're doing is when you are going to extinguish that flame, okay, what happens is you set that bell over the top of the candle. Okay? So very similarly, if you burn a candle inside of a closed jar, one, you're going to create a vacuum, and two, okay, all the oxygen is going to get used up. And when that happens,
Then the fire goes out.
when that happens, that vacuum sucks the candle down into or pulls into whichever, because the fire has been extinguished because it ran out of oxygen. It gets converted to carbon dioxide. So essentially, you're just drowning the candle of, or depriving it of oxygen. That's all you're doing. So what happens is, again, the amount of oxygen will be balanced by the amount of carbon dioxide that's produced, which will be a very small amount because you have that little bell over top of the candle. So again, it's just not a whole lot that you're utilizing. Okay. Does everyone have this content that wants it? Okay. All right. So we'll illustrate behind the screen on the whiteboard this reaction that you see. So one of the that takes place with this reaction, you have to have a possibly sometimes you could say a catalyst or something to cause it to react, because otherwise this mercuric oxide, I think is what it's referring to. Yeah, mercury 2 oxide or mercuric 2 oxide. And on your exam, when you're adding together those atomic masses, some of you had potassium ferrocyanide, some of you had potassium ferricyanide. Okay? So how you pronounce it will give you an idea on which type of element you're dealing with. That's why we say mercurous oxide or mercuric oxide. In this case, it's mercury 2, so it's mercurous oxide. Okay. So if you had, yes?
Can we go over number 2 on our packet
Right now.
after you're done explaining?
Better answer. Okay. So what you're seeing here, this red powder or this mercuric oxide is not going to do anything, okay? Because it's just not. So you add heat, which would be a catalyst, will cause them two elements to split apart. Oddly enough, when water was produced on the earth, it's actually fire that does that. It's actually the amount of oxygen in the air combines with hydrogen, and then once that goes through the process of combustion, whether it's a spark or some sort of heat, water vapor is then produced. And if there's enough, then you start pooling water itself. Okay. So, anyhow, does everyone have this content that wants it? Okay. So is this one number 2 then?
That's number 1.
It's calcium plus
Oh.
hydrogen, nitrogen, oxygen, 30.
Well,
We'll do that another day.
no, that's not what we're getting at. We said we're going to work on that mercuric oxide. Okay. Okay, so mercury 2 oxide, how would you write that?
M.
No, not M. The symbol for mercury.
HG.
Okay, what is the oxide ion? Okay. What's the charge of oxide or oxygen? Okay. What is the charge of the mercury?
Plus 5, I think.
No.
Plus 3.
No.
2.
Okay. Does that add up to 0?
Yes.
Okay. So what it says is adding heat will cause this to break apart. And when that happens, okay, here's your liquid that looks silver in the bottom of the tube plus oxygen. So if we left it like this, do you think that is correct?
No.
Why not?
Yes, it is. Plus 2, plus 9. No, you need 2 of them.
Need 2 of something, yes.
2 mercury. Oxygen.
No.
2 oxygen.
What, over here?
Yeah.
Can you be a little more specific when you say 2?
You're good.
2 oxygen on
Okay, I hear 2. I hear we're good. Which is it?
Plus 2 oxygen.
Plus 2 oxygen. Like this?
No, but you need 2.
Okay.
The number 2.
Oxygen's a gas, right? Oxygen's a gas, right? Is hydrogen a gas?
No.
Hydrogen's not a gas?
It is.
Okay. What do you notice about a gas called hydrogen in the reaction just above it?
Stable.
You people are saying it, but I think, but you don't know what you're meaning. You're saying 2. You're saying add 2, but you.
I just said that as a guess.
Okay. But in the top reaction, hydrogen is a gas, and when it's by itself, what do you need to put behind it? Okay. Is oxygen a gas?
Oh, yeah.
Just like hydrogen, oxygen's not a gas.
Oxygen is a gas.
Water?
See it.
It is.
Dave's breathing water, I guess.
Is oxygen a gas? Okay. Hydrogen's a gas. So that means,
So for the coefficient then? Yeah, that's what it is.
but you said add 2.
Before I said O2.
You said add, I perceived add 2. Okay? Now, so we've got 1s in front of each one of these. Okay?
Why do you have
Just quick talk.
Okay? So there's 1s in front of each one of these molecules, elements, and compounds.
Do you always?
Wait, can you do it behind them?
What's the one you
No.
say? Sun doesn't. Sun taught me.
1. Where do you see a 1?
2, 1, 1, 1.
Chris, that's for the top equation.
I can't see anything for the bottom. It's all a glare.
Okay, so what are some elements that you see?
Mercury and oxygen.
Okay. Mercury's left.
1.
Mercury's right.
1.
Oxygen's left.
1.
Oxygen's right.
2.
Okay, there's only one place that's out of balance. We've got 1 here, and we've got 1 here, or in front of the compound, I mean. We've got 2 oxygens over there. How do we get 2 over here? Okay.
But then you need to put a 2 in front of your other mercury.
What's 2 times 1?
2.
What's 2 times 1?
2.
Okay. But now your mercuries are not balanced.
You gotta multiply it.
By what?
By 2.
2 times 1 gives you?
2.
Okay. So what are your 3 coefficients that you would put through?
2, 2, 1.
Okay. 2, 2, and 1.
Where are you getting the 2s and the 1s? This does not make any sense.
Oh.
Okay. So when we first started, okay, there is a 1 in front of each one of these compounds. Would we agree with that? You would agree with that?
No, that's wrong.
Except, yeah, no, it isn't.
We haven't started yet. Okay? We erased everything. We're starting all over.
Can you erase their charges? That's getting me confused.
All right? Okay? So we had mercury and we had oxygen. Okay? We had 1, 1, 1, and 2. Okay?
There's 2 oxygen.
Because there's 1 oxygen here and there's 2 on this side. Okay? Okay. So what happens to balance that out, you have to put a large number called a coefficient. You distribute that through the entire compound. So we've got a 1 here, because 1 times 1, 1 times 1. That's what we've got. It's just 1. But you don't want 1, you want 2. Okay, so we change that to a 2.
So does that, I have a question. So that changes the mercury and the oxygen?
Yes.
You want it down.
Okay. I'm willing to bet that when we were illustrating that with zinc nitrate, we were explaining that and you're doing something else.
I wasn't in here.
Cleaning the shop.
Okay?
If I had to do it.
I thought maybe someone was explaining it to you at the same time we were working on this.
Didn't know what he was talking
Well, I can't help that. Okay. So, 2 times 1 gives you what?
2.
2 times 1 gives you what? Okay. Do we understand that?
Yes.
Okay, so we're all on the same page here. Left outside. Middle. Right side. Okay. So now your oxygens are balanced, but your mercury is not. You've got 2 to 1. So how do we get this number up to a 2?
You put a 2 in.
We put a 2 in front of there. Okay? Then once you do that, that changes this to a... Okay. So what numbers changed from 1s to 2s?
The first one.
First one? Is that it?
No,
Second one, 2.
Okay.
Third one was a 2.
All right.
No, it wasn't. He's just checking.
Okay.
So what happens when you have somebody teach you something?
What happens when you don't help clean the shop?
We will... This one, I'm just going to make up. It's not on your paper.
You didn't either. He was there.
Okay. That's what we're doing.
There's gotta be an aluminum in here.
Okay,
That H is F2, I think. Or that's how it is on the sheet.
so what happens is charges will not change from one side of the compound to the other. So this is +1, that's -2. So everything over here has a -2 charge, correct? Okay. Hydrogen's got a +1 charge, correct? What's 2 times 1? Okay. So now everything adds up to 0 there.
Mr. McKinney,
Yes.
close the blinds, please.
Okay. All right. Is everything on the product side written correctly?
Yeah. Aluminum 1.
Does the charges and numbers add up to 0 there?
Yes. No.
I hear yes and I hear no.
What's the charge of sulfate? -2. Adds up to
It said the charges do not change.
What's aluminum's charge? It adds up to -2. You have to have 2 aluminum.
Okay?
AL2. AL2.
All right.
3, or is it 3 sulfate then? No. No. It's 2 times 1. 2 times 2.
4.
The charges would not change. That's in column 3. Okay? So go by your negative ions. Okay? What's the least common multiple between 2 and 3?
6.
Okay? So the answer you get tells you what to put below. All right? So what is 6 divided by 2?
3.
Okay? So now this is where it gets to be a little tricky. You don't have 43 oxygens.
But your parentheses are.
Need parentheses around it. That's correct. Okay?
You have to have.
Yes, Chris.
Oh yeah. I can't see it. There's a glare.
Okay?
I can't see what he's putting it over.
Well, why don't you move then?
You have the freedom to.
Okay? Then, is everything on the product side written correctly? The answer would be no. You said it earlier, you just maybe forgot. Right. Because hydrogen's by itself. Okay. Now, this is where we said you don't have to write everything down that you see underneath the arrow, but for some people it works a little better. Some elements that you see.
Aluminum. Hydrogen. Sulfate.
Okay, now you can do sulfur and oxygen, or you can do sulfate. It's much easier if you leave it as sulfate, but you can split it up into sulfur and oxygen. Which do you prefer? Okay, we'll do it both ways.
Yes.
Okay, and okay, so aluminum's left. Aluminum's right.
2.
Hydrogen's left. Hydrogen's right.
2.
Sulfate's left.
1.
Sulfate's right.
3.
Okay? Now, this is what happens. If you choose to split them up, you can.
Sulfur and 12 oxygen.
Okay? So we've got 1, 3, 4, and 12. Okay? That's what happens when you split them apart.
That ain't bad.
Okay? So, what would be the best place to start here? We've got 1 in front of aluminum, right? Well, we need 2 there. That's a pretty easy fix. So that's done. Now, what about the sulfates?
You gotta make the left one so it equals 3.
Because we got 3 there. So we put a 3 in front of here. Distribute that through the entire compound. 3 times 2. 3 times 1.
Yes, I do.
Okay?
Oh, you gotta
Now,
use that hydrogen.
you've got 2 hydrogens over here. We've got 6 over here. So how do we get this up to a 6? Now, if you had chose to split them apart, okay, once you do that, that gives you 3. And then for oxygens, we've got, 3 times 4 gives you 12. It's much easier to keep these, but you can split them apart, but if you want a little advice, it's much easier to keep them together. So what are your 4 coefficients? 3, 2, 1, 3. 3, 2, 1, 3. All right. Anything else? Okay. That's where we'll stop for today. We'll catch up to you next time.